system of equations is when we have two or more equations and we're trying to find where they intersect, right? So sometimes they don't ever intersect, right? Sometimes they intersect more than once, okay? And sometimes they just have one answer, okay? So a system is more than one equation. Okay. And we're just looking for the point that satisfies all three or all of them, okay? So x comma y is a solution. We'll talk about what happens when we get into three variables in a little bit. Next. Okay. So sometimes we have one solution. So maybe we have a line that goes like this, and maybe we have another line that goes like this, right? And where they cross, this point right here, x comma y, is sitting on both of those lines, and so we call that a solution. Okay, that x and y value would be true when you place it back into both of those equations. Okay, that's the most common. Okay, what is it going to look like if we have no solution? Think about our warm-up. They're never going to touch, so we call them, what kind of lines never touch? Parallel. Okay, so if the two lines are parallel only has one R and then lots of L's. Parallel, they will never ever touch, okay? So if you graph that, or if you solve, right, and you get this recognition that these are parallel lines, you would just write no solution, right? Okay, infinite solution, okay, means you have, infinite means what?
Never ending.
Like a whole bunch of them, right? Like a billion. So if I had more than one point where these lines connected, like let's say they connected right here, this dot right here, and they connected right here. Look at my paper. Just look for a second. And then they connected right here, and 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 right here. And what do you notice about all of those infinitely many points?
I make a line.
And where's the line compared to the first one?
On the same line.
Like right on top of it. So the two lines are actually sitting right on top of each other. So when they're exactly the same line, okay, so these are on top of each other. That might not be the most technical way to write that, okay? Or they are exactly the same line. That's when we have infinitely many solutions. Bless you. Infinitely many. Okay, so the idea is that we're going to review solving systems, okay? And you're going to have this sort of toolbox that you're going to pull from and be like, hey, which would be the best method? Should I use graphing? Okay, the only time I would ever use graphing is one, if it was like crazy weird numbers, right? Like I might use technology to graph that. I'm going to let my calculator do the work. Or if my equations are already in y equals, okay? Or they're very easy to change to y equals. I don't need to do a whole lot of work, okay, ahead of time to force myself into graphing, okay? So graphing, you're looking for your equations in y equals mx plus b so that you can draw a real quick graph. Okay, so number 1 and number 2 are already in that format, so I would graph those, okay? So let's graph the first line here for number 1. All right, so which of these values are we going to start with? Y is by itself. We got a negative 5 over 3x and a minus 6. So which one of those do we do first? We're going to start with negative 6. That's our y-intercept. So if it's negative 6, we have to go which way on our graph? Down. So we're going to go down to negative 6. 1, 2, 3, 4, 6. We're going to put a dot there. And then from there, we're going to graph a slope of negative 5 over 3. So the negative 5 means we're going to go down 5. And which way is the 3?
Right.
To the right. Down and to the right, or up and to the right. So when we go down, 1, 2, 3, 4, 5, I fall right off the edge of the graph, but that's okay. I'm only one box off the graph, so I can still go over 1, 2, 3, and I can put my little dot right there. Okay, before I connect that line, my suggestion would be to get a few more dots so that we draw sort of a more accurate line. So instead of going down anymore, because we're going to fall off the graph, which way should we go instead? Up and to the
left.
3, 4, 5 to the left. 1, 2, 3. Put a dot. Up 5. Back 3. Okay. So the idea with graphing is that, fingers crossed, one of those dots that we just drew is where the lines are going to cross. Would anybody like a ruler? Yeah. This will be the first time I'm passing out the new rulers. Are they free? You get pink. Real men get pink. Sorry. I gotta fight over it. Okay, so the thing with graphing is that we need this line to be like as accurate as possible. So if I just put 2 dots and then I sort of like you sort of draw this really crazy line through them, when you draw your second line, it's not necessarily going to match up with what you have. So line all those dots up with the edge of your ruler. Draw a nice line that goes all the way through your graph. Okay, there's our first line. That's what we did last unit. Okay, and then we're going to do the same thing with the other equation. Is it already in y equals? Yep, so we're going to start with which of those numbers? The positive 5. And if it's positive 5, we're going to go which way? Up. 1, 2, 3, 4, 5. And put a dot. And then from there, we're going to go which way? Slope of 1 over 6. So 1 is going to go up, and 6 is going to go to the righty right. Are you already done? Up 1 to the right. 1, 2, 3, 4, 5, 6. If I do that again, I'm going to fall off the graph, so I'm going to go the other direction, go back to where we were, go down and back. 1, 2, 3, 4, 5, 6. Oh, do you see? See right there? See how it crosses right on that dot that we had? So that should be nice and easy to figure out what that ordered pair is. Okay, so this ordered pair right here is our solution. What is that ordered pair?
1.
1? What? Oh, it has one, yeah, okay. Yes, it has one solution, but I need to know the name of that ordered pair. What is x and what is y? X is, wow, those are really tiny numbers. Is that negative 6? Positive 4? One solution at negative 6, positive 4. Okay? And what that means is that if I put in a 6 for negative 6 for x and a 4 for y into both of these equations, they would both be true. Okay? So let's use our calculator to test that. Okay? The first equation says y. So what number can we put for y? What did we just say our answer for y was?
4.
4. And then there's an equal sign. Are you typing? Negative 5 over 3. Let me change that to a fraction. Fraction. Negative 5 over 3. And then what number are we going to put for the x? Negative 6. Put in parentheses. And then after the negative 6, or after the x says minus 6. So I put a 4 where the x, for where the y was, and a negative 6 where the x was. And when I hit enter, this should be true. Right? Or if you didn't want to do that, you could just type the last part with the negative 5 over 3 and be like, hey, look, it makes 4. That's the y value, right? Because you don't always have a graphing calculator when you're checking those ordered pairs. Okay, so here's the thing. When you're checking to see if a point is a solution, you can't just check one equation because it could be on one of the lines but not on both of them, right? So when you're checking for whether that's a solution, you got to do both of them. Okay, so we got to do the second one as well. Our y value is 4 equals, this time we have a 1/6. And then our x value is still -6. And we're going to plus 5 to that. So it has to work for both of them, otherwise it's not a solution. Okay? All right. So let's graph number 2. Is number 2 already in y equals form for us? Yep. All right. So the first one says y equals 5. So where would I go to find y equals 5? Just go, which way do I have to go to get to y is 5? Up. 1, 2, 3, 4, 5. So this is my point right here. So which way are we going to draw our line through that? Up and down or left and right? Left and right. So we want a line that goes right through +5, or a horizontal line. Helps if you make those noises. These are nice. No, don't be breaking my rulers now, okay? Just bought them. All right, what about the second one? What do we know about that line? It has a +7. So we're going to start at +7, which is right above where we were, 2 points above that. And what's our slope going to be this time?
To the right, 2.
No.
To the right, 2.
No.
Down 1.
What's the slope? Give me the number. 2/1. What does that represent?
Go up.
Rise first. Rise over run. So it's always up or down first. And then over. So we're going to go up 2 over 1. And I fall off the graph, so I'm going to go the other way. Down 2, back 1. Hey, look, I hit right on the line, yeah? Down 2, back 1. So that's probably enough. So you're looking for that spot where they intersect. So what is that ordered pair right there where they meet? -1, 5? Has to have a y value of 5. Okay, so for today, the first part of our lesson is just reviewing graphing, because some of you still need extra practice, right? Practice. But sometimes it's not always in y equals, right? Like both of these first two problems, they're both already in y equals, okay? So let's do one where we're not given a problem, like it's not in y equals and we got to rearrange it, okay? But again, after today, after you practice today, practice graphing, change it to y equals, do the things, and then we look at all of our other options for ways to solve systems, you can pick whichever one you like best, right? Like you need to know how to do each one of them. And then you're going to say, hey, this one's sort of set up for graphing, or hey, this one's sort of set up for elimination or substitution or whatever it might be, okay? So I would never graph if it's not already in y equals. That's just me. I'm not, like there are easier ways to do it than with graphing, okay? All right, so let's change number 3 to y equals. So before you start, change each equation to y equals, because you can't graph unless it's in that form, okay? So if my first equation, I'm going to write way over here, and I'm going to kind of write small, because this one takes sort of a lot of work to rearrange, okay? So if this is my equation, and I want y to be by itself, what do we need to get rid of? The 6x. And when I move that 6x to the other side, we have to make it negative. And I saw that on the test all the time. People were moving things over the equal sign and leaving it the same sign. Like, let's just move things around all willy-nilly. We can't do that. If we move it across the equal sign, we got to change the sign. So the -5y is going to stay there. And then our equal sign, the -6x is going to go in front of the -45. And then we're going to divide by all the way across whatever's in front of y, divide all the way across by that. So -6 divided by -5. Negative divided by negative makes
Positive.
positive 6 over 5. And then the x. And then negative divided by negative is
Equal
positive. 45 divided by 5 is 9. Okay, so can you graph that?
Yep.
Where does it go? Thank you for saying you can.
Okay.
So we're going to start at 9. If you need to write out, like, this is my y-intercept, this is the slope, if that
Yes.
helps you to write it out each time, you can go ahead and do that.
Never mind.
What?
Never mind.
What's wrong? Tell me.
It's gonna go off the graph.
It is going to go off the graph. So instead of going up and to the right, we need to do
Down
the
to
opposite. So we're going to go down 6 and back 5. 1, 2, 3, 4, 5, 6. Ooh, I saw it. Ooh, these graphs, y'all. 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay, so fingers crossed, one of those is going to be our answer. Most likely. Okay, so again, before we graph the other one, we got to change it into y equals. Change to y equals first. So we've got 2x plus 2y equals negative 4. So if we want the y by itself, we got to get rid of the x. So we're going to take this positive 2x and we're going to move it to where? After the equal sign in front of the negative 4. And when I push it back there, it's going to become negative 2. So we have a positive 2y right here in the middle. Positive 2y, and we're going to move the negative 2x to the back, and then a minus 4. And what are we going to divide all that by to get y by itself?
2.
Divide by 2. So negative 2 divided by positive 2 makes negative 1. And negative 4 divided by 2, negative 2. So this slope, the number in front of x, doesn't have a number under it. So what number do we have to put there so that when we graph it, we have moving somewhere? Right? So this one's going to go down 1 to the right 1. So we're going to start at negative 2. And then down 1 to the right 1. Down 1 to the right 1. I probably don't need to go too far that way because that's not going to be where my answer is, right? Our answer needs to be back the other direction. So we're going to back 1 up. And it hits right there, that dot that we already had. Okay. And that number is negative 5 and 3. Just trace it back to your x and your y. X is negative 5, y is positive 3. Okay. Again, today may be the only time that you actually have to change that into y equals. If after we show you the other methods, like there's an easier way to just do this algebraically without graphing. Plus you don't always have like a graph handy, right? The whole point of this is that you already given a graph and it's really easy to just sketch a quick graph. Okay. We don't really have to do that all the time. Okay. All right. So let's look at. Actually, hold on. Let me look at something. No. Are y'all are okay with the like recognizing if the lines are parallel, recognizing if they're the same line? Okay. Okay. I'm not gonna worry about that. All right. Substitution. I'm going to admit substitution is maybe my least favorite, but it's nice to have, okay? But I don't really use this one as much. I use elimination way more than that. We'll do elimination next time. Okay, so what does the word substitute mean?
Change
Marquise.
something for something.
Change something for something else, right? Marquise, you with me? Okay, so we're going to replace a letter with some other stuff, right? Okay, so what I notice here, I'm going to grab a highlighter. Y'all don't fuss this. Okay. Okay, do you see right here where this first equation says y equals all of that stuff?
Yep.
So all of that stuff that I highlighted is the same as y. Everybody with me? Eric, you with me? All of that stuff that's right there is the same as y. So down here where this y is, I could take out the y and put all that other stuff in its place because they're the same, right? And then I have an equation that only has x's. Does that make sense? Yes? Okay, so we're going to do that. We're going to take all of this stuff right here, and we're going to put it right there where the y is. So we're going to get rid of the y.
Can I get a highlighter?
We're going to get rid of the y. In place of the y, we're going to put the negative 7x take away 1. Okay, that was all the y stuff. And then we're going to say that's the same as x take away 9. And now I just have a real quick equation that we got to solve for x. Okay, so we should only have one variable left after we do that replacement. Okay, so I want to get this x over to the other side. So if I get rid of this x from here and I move it over there with that negative 7, it's going to be what? Take away 1x or take away an x. So that's going to go away. And we're going to have negative 8x's on that side. Negative 7, take away 1 more. And at the same time, we can get rid of that minus 1. We want the minus 1 to go the other way. So how do I get rid of minus 1? Plus 1. And it's going to go over here with the 9. So that's going to make that go away. And negative 9 plus 1 is negative 8. And then last step is divide. Divide by negative 8. Negative 8 divided by negative 8 is positive 1. Okay, so on my answer is this ordered pair where I have a value of x and a value of y that works for both equations. So this is part of my answer. This is going to go down here in the x spot. All right, got that one already. Okay, so now what I have to do is, let's go back to our instructions. We solved one equation for x or, we already did that. Solve for the remaining variable. We did that. Substitute your answer into either original equation to find the other variable. So I'm going to take this x as 1, and I'm going to come back up here, and I'm going to put it in, most likely, I'm going to put it in the one that I had highlighted, or the one that I used to start with. Okay? I'm going to put this x negative 1 back in, or sorry, x is positive 1, back into this. Okay? And so this equation says y equals negative 7 times whatever x is, take away 1, right? And what did we just say x was? 1. So I'm just going to stick a 1 right there. Notice that all of this is together on one side of the equation, or on one side of the equal sign. So I could just type all of that into my calculator if you did not want to do it in your head. Or you could do it real quick in your head. Negative 7 times 1 is?
1.
What? Negative 7 times 1.
Oh, negative 7.
It's negative 7. Take away 1 more.
Negative 8.
Should make negative 8. If you need your calculator, type. I think we would all agree that that would be negative 8. So this is going to be our point where our two lines would cross. Easier than graphing?
Yep.
It depends. It depends how comfortable you are with solving equations, right? If you're still struggling with that, guess what? You need to ask for more help. So, okay. All right, so here's what we're looking for in substitution, okay? In substitution, you are looking for x equals or y equals, like all by itself, okay? So, do I see that on number 8? Do you see a x equals or a y equals all by itself? Yep, so all of this stuff right here is the same as y. So where could I put that in the other equation? Where the y is. Great, Deshaun. Right here where the y is. We're going to take all of that stuff and we're going to shove it in that spot. So all the other stuff sort of needs to expand a little bit and give us space. So I'm going to put all that stuff in parentheses. And then we're going to equal that to the 42. So inside here we have, what's this, negative 5x plus 30. So I just take that second equation or the other equation and I take the y out and I'm going to put all that stuff in its place. Solve for x. Does everybody feel comfortable doing that? Be like, I've never seen an equation like that in my life. Okay, distribute. So 7x, 3 times negative 5, 3 times 30. So now we got a couple x's on the same side. So I don't need to move them. I just need to combine them together. So how much does this make? They're on the same side. Just push them together. What's 7 take away 15? Negative 8. So we got negative 8 x's. Can we get rid of the 90?
Yep.
Take away 90 from 42. What does that make?
Negative 48.
Thank you. Last step. Divide by negative 8. Negative divided by negative is positive. 48 divided by 8 is 6. So somewhere down here, you're going to write your big answer. In our answer, we're going to put 6 where the x is. And then how are we going to figure out what y is? Put it back up here. Put it right in there. So it says y is negative 5 times whatever we just got for x plus 30. Interesting. What's negative 5 times 6?
30,
Negative 30. So negative 30 plus positive 30 is just 0. So that's our ordered pair, 6, 0. Could 0, 0 be an answer? It's okay. 0, 0 is the origin. No, it's an okay. Some people are like, ooh, I don't have a number there. 0 is still a number. It has feelings too. Okay. So what about number 10? Do you see a variable by itself?
Yep.
Do you see the x? Is it all by itself yet?
No.
Okay. So I'm going to take this equation and I want to get x equal like by itself. So I'm going to move whatever else is over there to the other side. And so when we do that, what's that going to be? Got to get rid of that minus 7y. So when we push that over to the other side, it becomes plus 7y. And then the 53 doesn't move, so it just stays plus 53. So you see how easy that was to get x by itself? That's when I would use substitution. If it's super easy to get one of your variables all by itself. Okay, so all of this stuff now is going to go in place of which letter? X. In this equation down here. So right here where the x is, I'm going to put parentheses. I'm going to shove all that stuff in its spot. Negative 4, big old parenthesis, take away 5y equals 19. And inside that parentheses, 7y plus 53. Okay, so the only difference here is we're solving for y now instead of x. It's still all the same process. What are we going to do first? Yep, so we're going to distribute the negative 4. Negative 4 times 7. Negative 28y, and somebody tell me what negative 4 times 53 is. Negative 212. Thank you. Okay, here's where people were messing up. See how these y's are on the same side?
Yeah.
So I don't want to plus, I don't want to do opposite because the opposite's going to move them across the equal sign. So I'm just going to pretend that this minus 212 isn't here right now. And I have negative 28y take away 5 more y.
Negative
So it's going to
33.
combine those together. Negative 28 take away 5 more makes negative 33.
Yep.
And then get rid of the 212.
You subtracting that?
Yeah, so you're just going to do negative 28 take away 5, like whatever it says. Don't change the signs on it. Just do whatever it is. So how are we going to get that 212 to the other side? Plus 19 plus 212. 231. Is that right? 231?
Yeah.
Does that divide by 33?
Yeah.
Divide by negative, so it's going to be negative something. But 7 maybe? Okay, so now in my answer, y is negative 7. So in this y spot, that's going to go at the back here. We're going to put the negative 7, and then we got to figure out what x is. So where could we put that negative 7 to solve for x? So do you see right here where it says x equals all by itself? So if we put our negative 7 back here, that'll give us our answer. So x is 7 times whatever plus 53. 7 times negative 7. Negative 49 plus 53. 53, take away 49, 4. All right, so we didn't have any here that were parallel or no solution. So I think 11 is one of those special cases. Let's hope this one be our last one. Okay, so here's the thing. For today, okay, do you see how number 12, see how none of those have an x or a y like all by itself? Like all the x's and all the y's have a number or a coefficient in front of them. So we are not going to use substitution for that problem. Like you can do it, it's just way more work because you got to solve one of these equations for x or y first, and then you got to go through all of this other stuff, right? So not the best situation, okay? What about 11? Do you see an x or a y by itself?
Yep.
Like no number in front of it? Yes. So right here where this y is, I could get that by itself. So we're going to do that. What about on number 9? Do you see an x or a y by itself? Or right here?
Mm-hmm.
So we could do that one if we wanted to, right? But this, like, no, okay? No x or y by itself. We'll do that using another method, elimination or whatever for tomorrow, okay? All right, so let's do number 11. This is going to be our last one. Okay, so can you change number 11 so that y is by itself? I'm going to tell you to be careful because what's in front of the y? A negative. So when you move the x over, it's not just y by itself. It's a negative y. And then you got to get that by itself. Okay? Or you could be fancy and move the y to the other side so it becomes positive. Yeah? If you want the y to be positive, you could move it to the other side and then get the other stuff away from it. You got a couple options there. Ready, set, go. Get y by itself. The second equation here for number 11. Look at my paper. Did everybody get this? First step? Okay, so when you get rid of this 3x and you move it to the other side, do you see what's left there with the y? See how it has a subtraction sign in front of it? You got to bring that down as a negative. Yeah.
I thought it was switched.
Only if you move the y across to the other side and leave the x where it is. Okay, so here's what I'm going to do. You could mathematically, like we could divide all these by -1, right? What happens when you divide a number by -1?
Becomes negative.
It changes the sign, right? It doesn't change the number, it just changes the sign. So I need this to become a positive, right? And I need this to become a change from negative to positive, and I need this to change from positive to negative. So you could just go through and change each of those signs, or you could divide through by -1 if you already did that. Okay, but this should be our final answer. Y equals positive 3x, take away 5. Okay. All right, so before we do any of the other mess, can you compare our answers? Okay, so right now we have a 2y equals 6x plus 10. And down here we have y equals 3x, take away 5. Do you notice something about those?
They're all doubles.
They're doubles, right? 2y and a 1y, 6x and a 3x. But then we have a positive 10 and a negative 5, right? So they're not exactly the same. If this was a plus 5, these are the exact same line. They would be like sitting right on top of each other, and that would be infinitely many solutions. I don't even need to do any more work from there. Okay, if you recognize, hey, if I times this by 2 or divide by 2 or times 3 or whatever, and I get the same thing, infinitely many solutions. Okay, this is most likely going to be no solution. This is most likely going to be parallel since the x and the y are both the same. So let's just prove that real quick. So we're going to take all of this stuff that says y equals all of that, and we're just going to shove that over here where the y is. So we'll have the 2 with a big old parenthesis equals 6x plus 10. Just rewrite the original equation, shove all that stuff in its place. So distribute 6x minus 10 equals 6x plus 10. Tell me something clever. What's going to happen to our x's? They're the same, right? 6x, 6x. If I take away from one side, it's going to go away on the other side. I'm going to be left with negative 10 equals positive 10. What do you know about that? That is that true?
Yep.
Can negative 10 equal positive 10? I wish the bank thought that. Negative $10 is very different than positive $10. Unfortunately, these are not the same. This is no solution. Your x's are going to cross out. You're going to be left with numbers that don't match. Okay, if your x's cross out and you're left with a true statement like 5 equals 5, that's infinitely many. Right? Okay, again, for today, I just want you to practice a little bit of rearranging to y equals. Right, we got to be comfortable with that. It will help with your test corrections as well as you go through that. We're just going to practice